Hello everyone, I hope you are doing good. In the previous video, I showed you diagrammatic of what cube is and how we do operation like how to input, delete and all that. Today we'll be doing using code. So today we'll be doing using array. In the next video, we'll be doing using linked list. So let's start coding. So there is nothing new here. I think you know these two lines and there we are int main and just we printed out that today we'll learn about q. So there is nothing to more to know here. So let's start. First we'll create a class. Let's create a class called q. The name is a little bit different, just it could be just a q and it will mean the same. Okay, so first we'll create some array. We'll create an array. Let's call an array. We'll create an array called my q, and we'll give it a size of 5 so that it becomes easy to understand and it will be a little less complicated, or it will be of small size. And we know that in q there are two more number, there are front and rear, that will say you which is the front element and which is the rear element, or which is the one that the pointer is pointing now. Okay, now let's create a public. In the public we'll set the value of front and rear, and I already said you in the previous video. And front and rear in the creation has a value of -1. If you don't know what's the previous video, there I explained nicely of the values what it should assign in the beginning and in the end. Front is equals to -1 and rear is also equals to -1. So that's it for construction of q, and we give the value of -1. Now we'll create some function. The first function we'll check if it is full or not, whether the queue is full, because if it is full we cannot add any more element in the queue. So we'll write is full, and it is a return type boolean because we want to return is true or false. Is full. Now is full. Wow. How to know it's full? Let's go to the figure one more time and I'll show you. You can see that this is a full because you can see all are green, previously it was white. If all are full, then the rear is pointing to this, the last element or the maximum size, and the front is pointing to the first or the 0. So we'll just write for full, the condition is if our front is equals to 0 and rear is equals to 5, or the maximum size that the array is created. If our front is 0 and rear is 5, then return true. Return true. Else return false. I hope you got this line. There's nothing new in this line. So we just wrote that if our front is 0, I don't know what is giving an error. Let's see. Expression must be modifiable. Modifiable I value. I don't know what is giving, but nothing. I don't feel there is any type of error here. Everything is right. So we'll write that it'll return true. Otherwise, if it is not 0, if this condition was fulfilled, then it means it is not full. So we'll return false. Now we need to create one more. We'll write that if our is empty. What if our queue is empty? If it is empty, we cannot dequeue or we cannot take out element from it. So we'll write one more function of type boolean. We'll write is empty. Is empty. In empty, what is the condition we need to check? Let's go back to the figure one more time, and we can see that if it is empty, let's make it white in color so that you know what empty means. Empty means there is no 8, no 7, no 6, no 5, no 4, no 3, no 2, no 1, no 0. If there is nothing, then even the pointer will not point to 8 now, and front will also not point to this. Both of them will be equals to -1. So I hope you are getting this. When there are no element, rear and front points to -1. So we'll adjust this condition. We'll write that to check it is empty, just check if front is equals to -1. If our front is equals to -1, return true because it's empty, then return true. If it is not pointing to 1, then return false. So that's just it. Okay, there's an error here but not here. Why? I'm not understanding. So we'll figure it in a later part, but for now it is in a good way. Okay, the error is gone because we did assignment this way and this is relational operator. Okay, it's gone. Now we need to enqueue and dequeue, means we need to add members and delete member. So we'll add a function called enqueue and one more function called dequeue. So let's start void enqueue. Enqueue means to add element inside it. So we'll just put a data here into new data like we did in everything, or you can just write value also because new data we used in linked list. So I don't want to confuse you, just you can write here value. So it seems easy. And let's start our functionality. So if it is full we cannot add, so we'll write if is full. We can see here we wrote a condition what is full if front is equals to 0 and rear is equals to the maximum size or equals to 5 because 5 is the or maximum size of queue. So we'll write if is full. If it's true, then cout queue is full. Okay, that's what we wanted to do. If it is full, just return this, and else what if it is not full? It's giving an error. Identifier is full is undefined. Okay, why is undefined? Okay, let's make it capital. Now it will be defined. Else, what if it is not full? Else we want to put element inside our queue. So what are the things we need to do? We need to increase the value of front and we need to increase the value of rear also, and we need to insert the value. So first we'll increase the value of front. Now the value of front will be 0 because this will be the first element, and you know that front, you can see here in the figure when we add something, you can see here when we added something, the front is always pointing to the 0 or the first element that was inserted, and rear is pointing to the 1 that is the last element added. So we'll just write here, so we'll change the value of front equals to 0 and rear is equals to, or we can say rear plus plus, means the value of rear will increase as we include more and more data inside the queue. So that is the condition for front, or this else condition. If it is not full, then what should be done? And now we'll add element inside our array. So we'll just write my queue and we'll just put the value here. We want that whatever the value of rear is, so you know that rear is the value of the element in which we added recently. So we'll just write here rear. In the value of rear, just put the value of the value that is passed in this as an argument. So we'll add equals to value. Now the value of rear will change every time because we added a plus plus here. The value of rear will change every time. So for first it will change to 0, then because it is -1 in the beginning, you can see here it's -1. So when we call enqueue, it will change to 0. So my queue 0 will be equals to value. Similarly, it will go on increasing, and you can see that it will be full when for one condition it will not run when it is full. And what is full mean? When rear is equals to 5. So that is the breaking condition. So this is what is happening here. Now we want to print out also whatever the value is entered. So we'll just write cout and just print the value of it. Value. We'll just print out the value. ENDL. So we can know the value of one by one after each one. So that is the end of this enqueue. But there can be one more thing. Value of front should not be equals to always 0. It should be 0 when earlier the front was -1. So we can add one more thing. We can write that if front is equals to -1, then add this, then make the value of front equals to 0. So it becomes easy. So when this -1, because it is the means nothing is added, then make it 0, because we want that when something is deleted, the value of front should go to the first element after the deletion. So that is it. Now we need to dequeue it. What is dequeue? Dequeue means taking an element out. So we'll just write void d and q, QUEUE. Okay, that's a tough spelling because q is just, you can write the simple q, and but we can't do it here. So here also we need to pass a data that is to be deleted. So we need to delete something, so we'll pass it, we'll call a data, we'll call a value here, int value. This is a separate value of what we wanted to delete. So before deleting, we need to check if it is empty. If it is empty, we cannot check, and we already wrote a condition when it should be empty, when front is equals to -1. So we'll check the condition first. If is empty, if the queue is empty, we'll return cout queue is empty, because if it is empty, we cannot take out any element from here because it's already empty. From empty, how can you take out something? And if it is empty, we'll just write is empty, and we'll change the value of front and rear. We'll change front to -1 and rear to -1. Why we want this? Because when we start dequeuing, at one time it will satisfy this condition. Okay, let me come here to the here. You can see that when we start deleting, you know that deleting start from here. So okay, this is deleted. I think it's not deleting. Okay, you can see at first this will get deleted, then this, and so 3, 4, 5, 6, 7, 8. When all are deleted, there is no pointer. There is no pointing. You know that when there is no pointing, then we point to this -1. So at one time, when all of these are dequeued, means one by one all the elements are cut off, then we know we need this condition to break this loop. So we'll write that if it is empty, then print out queue is empty and change the value of front and rear to -1, which is earlier pointing to the last element, front and rear. Okay, now we need to dequeue. So what is the condition that will apply in dequeue? We'll just write else, because now it is not empty. So in the else, we'll write that we need first increase the value of front. You know that we need to increase the value of front, because when we start deleting, the value of front goes on adding. It goes closer to rear. So at first rear and front both are 0, 0, but rear increases as we add more element. But when we delete something, front goes closer to rear. So else we'll just increase the value of front. Front will be added and it will come closer to rear. So that is it. Now we need to print out what is being deleted. So we'll just write here cout, and we'll write what is being deleted. So we'll write deleted. So this seems not so obvious in array, but when we'll do using linked list, this will be more comfortable. You'll be more comfortable in knowing that what is really being happening. So we'll just write deleted value, because the value what is being deleted, we'll delete the value from QUEUE, from the queue. So this is just being deleted. In the array, it's not so much, means we are not comfortable. We are just pointing something else, but our size remain. But in linked list, we know that we can delete something, means it can go out of the node. So when we'll be doing using linked list, you'll get this in a more better way. For now, you just take the concept. You take the concept so that it becomes easy for you to understand when we'll do for linked list and all that. So, and we'll just return out the value. Okay, that is it. Okay, it's not taking a return. I think I forgot to add int. Okay, I added void. We need to add a int because we wanted to know what is being deleted, and that's why we are returning the value that is inside here. You can see here, where is the value? Okay, you can see this value. We want to delete this value. So that is it. Now we can just call to display it. Whatever we want to display, means we want to display what is the queue, and after dequeuing it, what is the value that remained. So we can just do using we'll call one more function called delete. So let's write here void and call it delete. We cannot write delete because delete is an operator, and we cannot use the name of an operator while it's not delete, it's display. sorry guys, display q. Okay, we cannot use delete. Why I said that? Because delete is a keyword, and we cannot use keyword as the name of function because that will give an exception, and we don't want to face any error. Okay, first we'll create an integer of type I, then we'll check that if our, now we need to check some conditions, like we need to check if our aq is empty. If it's not empty, if it is not empty, then we want to print out whatever is there. So we'll just write first, if our queue is empty. If our queue is empty, just say cout queue is empty. So we'll just print out this. But what if it is not empty? If it is not empty, then we want the values. So we'll write else, and we'll print the values. We'll write cout and call the front. Means we want to first say what is it when we are displaying, what is the front pointing to. Means the front, you know that there are two integers in the top, you can see here, front and rear. First we'll say the value of front and rear, so you understand that the value of front is changing when we dequeue something. So we'll add front. So first front will point to front that is currently being pointed. So we'll add front, and we'll just end the line. Second, we'll print out what is the rear. So we'll print out what the rear value is now. We'll just write front cout rear, and we can just print the value of rear. Okay, and now we'll print out the values that is inside the queue. So we can just use a for loop. We'll just write for I is equals to front. We know that the loop will start from front because you can see here the front, the value of front will be first, it will always point to the first element. So it will start from first element and it will just go on this way. So we'll write from I is equal to front till I is less than equals to rear, because we want to go till the rear element is there. So we'll write I is less than equals to rear till the rear one, because rear, you know that rear value increases as the element are increased. So element will increase up to rear value, and we wrote here what is the max value. The max value is 5. It can go up to 5 because there are only 5 elements. So we'll just write here I is less than equal to rear, and we'll just increase the value of I. So that is our for loop. Now we need to print out what is the values inside this. So we'll just write cout and the values inside my queue, and print the value what was inside this. So that is what we want to print. So we'll print out this, and we'll just add an end line, so that, and before this we can just write here cout, and we can write queue elements. Just make it capital, queue elements. Sorry. And now we'll run the for loop. We can add here end line so that it comes in the next line. So it will write queue element, then we'll run this loop, and we'll just print out all the values. Now what if you want to dequeue, enqueue, and all that? So this is just for the displaying. We'll display everything. Now we displayed everything. Now let's come to main function, and here we'll do all the, this means enqueuing and dequeuing. First we need to add an object of our queue. So we'll write queue, and let's create an object of, what is the object? Let's create obj1 or q1. Okay, it seems good. Q1. So this is our q1. Now first we need to we'll create something. Means we want that we need to enqueue it. Means we'll add some element. So we can write q1 dot enqueue. In the enqueue we need to element 1. Suppose we are adding 1, and we'll add one more, q1 dot enqueue 2, and last element we'll add is q1 dot enqueue. Okay, enqueue is not showing because we did not add here. So we'll add enqueue, and we'll write 3. So we added 3 elements. inside the queue, and we'll try to display it. So we'll write q1 dot display queue, and let's call it. I hope we don't face any error because I did not see any error till now. Just let's run it. Okay, you can see here why first 1 2 3 is getting printed, because when we are adding any element, you can see here when we did enqueue, where is our enqueue, we printed out. So let's cancel out this line. Okay, let's cancel out this line. Sorry, it was in Python. I'm really sorry guys. So let's run it one more time. Okay, you can see that the front value is 0 because we know that how many the value, it does not matter how many value we added. For the first time, front will always point to 0. Here you can see in the figure, you can see here that the front will always point to 0 whenever an element is added. If something is added, then the front will always point to the one that was first added. So this was first added. Okay, there is an error because our this pointer mat is become too thin, so that our color is spreading everywhere. So if we decrease it, I don't know if we, let's try one more time. Okay, you can see here now front will always point to the one that is first added, but the value of rear will change to the item that is lastly being added. So if now 3 is being added for the last time, so rear will point to 3, but front will always point to 0 because these are the first element. But when first element is removed, you know that the element that is added first will remove first. So we'll write that if the element is first removed, then the value of front will change and it will just come here. It will change to the item that is now the first element of this queue. So that is it. So we'll just write the condition here. We saw here front will always point to 0, but the rear value is 2 because we added 3 elements and counting starts from 0. So this is 0, this is 1, and this is 2. Now let's start dequeuing it. So we'll write dequeue. So to dequeue, we just write dequeue q1 dot dequeue. So you know that which element will be deleted. So let's just copy out this line. I could not still solve this problem of why we cannot display 2 times. I asked you, I hope you know or you don't know. Let's see in the comment if anyone's comment out. So you can see here the value of rear is 2, but the value of front is 1. Okay, wait, let's go to dequeue. Let's cut out this line because this is not making anything. Okay, let's clear out this first and run it one more time. We'll just uncomment this and okay, and we'll comment this and run it one more time. Sorry guys, there is some error, means I printed or something more. So this is the first one we saw, the front is 0, rear is 2, and the queue elements are this. Now when we want to dequeue it, we'll just uncomment this line. So we dequeued something and let's print out. You can see that now the value of front changed to 1, but the rear remains changed same because we did not, when the value is enqueued, then the value of rear change. But while dequeuing, the value of rear does not change, but the front goes closer to rear because you can see earlier front was 0, rear was 2. Now front is equals to 1 and rear is equals to 2, means front is moving closer to 1. And see the element which is being deleted. In the stack, 3 would have been deleted, but here the element that is deleted is 1 because this was the first input, because you can see here this was the first input, so 1 will be deleted first, whereas in stack this is the last input and last will be deleted. So let's dequeue some more time. So we'll just copy out this and run one more time and see what will be done. I haven't done this, so this will also be new for me. You can see the value of front is also 2, the rear is also 2, and queue element is 3. Let's dequeue one more time and let's see what happens. Okay, the value of front is increasing, whereas the value of front should not. Oh, I know why it's increasing. It's increasing because our queue is extended to 5. Our queue is extended to 5, and you know that in array that is a small problem we have. I think we can fix this, but it will take up some more time. I can fix it. If I'll fix it, I'll upload it on GitHub. I did not try it while writing the code, so this may be like small type of error, but I'll solve it. This is not a big problem. But in linked list, this problem will not come, because in linked list we'll straightly free away the memory, but here we are not freeing the memory. So it's like front is going above rear, but it should not go up to that. So yes, there are some errors, and I'm also not so expert in this. I'm also learning with you the same time. So I may face some problem. If you have idea, you can just comment out so we can learn it together. So that was it for today, and that was the queue with array. In the later video, we'll learn about queue with linked list. I hope you tune in and access the playlist so that you can give access to all the lectures that I have been delivering in C++. So guys, thank you for watching. See you in the next.